Section 2 says the straight line of the graph x equal to 5 minus 3y intersects the x-axis at P and the y-axis at Q. Determine the coordinates of P and Q. No, say the x-axis intercept, y is 0. So the x-axis intercept, we know that y is equal to 0. So when you put y equals 0, you'll get x equal to 5 minus 3 times 0, and that does work out to be 5. So that means that the coordinate of P is going to be the x value of 5 and the y value of 0. So that is P. P is 5, 0. That is P. The next thing we need now is for Q. So now Q, to determine the coordinates of Q, the coordinates of Q now we know that the y-axis x is now 0. So now that the y-axis intercept, we now say x equal 0. Since x is equal to 0, what's going to happen then is x is now 0. We get 0 is equal to 5 minus 3y. We bring over 3y to get 3y equal 5. And so we end up get y is equal to 5 over 3. So that means that the point, the y-axis intercept point, which is Q, it's going to be 5 over 3, comma 0. That is Q. 5 over 3, 0. So we can just put that right there. So 5 over 3. Doesn't look too pretty, 0. That's that right there. So all right. So if I were to actually draw this line, like my life to draw them line here. Let's say I did want to make y the subject from day one, right? If I did make y the subject, this would be 3y equal 5 minus x. I'm just writing down what the line would be. 3y would be equal to 5 minus x, and then I divide through by 3 to get y would be equal to negative 1 over 3 times x plus 5 over 3. So if you were to draw how this graph look, it looks something like this. All right, it's have a negative gradient, so it's in the first quadrant. And this right here, so would that be right here, so would that be the y-axis intersect Q, and this would be the x-axis intersect P. All right, that's what we know. Now the next thing that they say is calculate the length of PQ given your answer to 2 decimal places. Now to find the length of PQ, look at this. If you have a triangle, right? This is the base. The base of the triangle is from 0, 0 to P. So that have a base of 5. And the height is from down here up to Q. And that would have a height of 5 over 3. You don't see it, this opposite. Because this is 0, 0, and this is 5, 0. So the base is 5. To go from 0 to 5, 0, that is 5. And to go from the origin to Q, you move up by 5 over 3. So now that means that the distance QP, we can use Pythagoras Theorem. So the distance QP or PQ is now just the square root of 5 square plus 5 over 3 all square. That's just Pythagoras Theorem. So we use Pythagoras Theorem to get the answer. So come do that now. The square root of 5 square plus, in bracket, 5 over 3 square. So work that out, and what we get is 5.27. But they said they want it to 2 decimal places. So can write 5.27. And remember that when you find the length of a line, just write units. All right, just write units. That's PQ. All right. Now this question says R is the midpoint of PQ. find the midpoint of R. All right, so we need to find the midpoint of PQ. Remember how midpoint go? Midpoint is, so the midpoint, so we can write that R, the coordinates of R is a half the two X term them. So you look on the two X term them and divide it by 2, when you add them up, and look on the two Y term them, add them up and divide it by 2. So see 2X them here. P, remember P is 5, 0. And, oh, so me have it right, yes, already. So 5, oh, shoot, snaps. I almost give it away, but I didn't. This is supposed to fix. The X part is supposed to be the 0 here, so, and the Y part is supposed to be the 5/3. Fix that before you submit your answer. Fix up this too. All right, fix up that too. Don't worry about that. So we'll make sure fixing it. All right, we're fixing it. Didn't realize I put the X part first. 5/3. So fix up that now. All good. We're good, man. We're good. All right, so now going back to around here now, we want the midpoint. So 5 plus 0 divided by 2. So that's going to be 5 plus 0 divided by 2. Then the midpoint of the two Y value them. The two Y value them are 0 plus 5/3 divided by 2. So when you work it out now, R just going to have coordinates 5/2. Some people might want to write that as 2.5. And 5/3 divided by 2, that should be 5/6. But if you're not sure, you can just do this. 5/3, and then you divide it by 2. You get your 5/6 if you're not sure. So that's the midpoint, meaning that's the coordinates of R. Q. Now the next part says the function f and g are defined as follows. It tells us say f of x is 5 minus x, and g of x is x squared minus 2x minus 1. It says the graph of f and g of x meets at m and n. Determine the coordinates of m and n. So what they're asking you to do is solve them simultaneously. So call f of x y and call g of x y. So what we usually do to solve these two simultaneously is you substitute the line into the curve. You sub the line into the curve. No, this is the line. Which one is the line? The line is 5 minus x. So we're going to substitute 5 minus x. We're going to substitute 5 minus x as this. So we're going to get 5 minus x is equal to x squared minus 2x minus 1 by equating the two of them. So now what we're going to end up getting now is bring over to one side, we're going to get, I'm going to bring everything to the right side and equate the left side to be 0. X squared, carry over this x, I get, add x to both sides, now I get minus x. Because I'm not sure if this can be factorized, I'm just using my calculator to see if it can. B squared minus 4 times A times C divided by 2 times A All right, so that means I made an error because I'm getting math error. So I think I would have subtracted incorrectly. Let me see, I bring over this to get minus x. Okay, when I subtract 5, I don't get plus 4. This becomes minus 6. So see it right there? This is minus 6. So let us justify or fix that. That's minus 6. So sorry, now I can factorize it easy. All right. Which two number when I times them, I get 6. When I add them, I get -1. That's a 3 and 2. So even without wasting time, it's obvious. This is going to be x, x. This is then going to be 6, not 6, 3, and 2. This is going to be minus, and this is plus. If you don't follow what I did, all I did was, let me put it in a line up here. All I did was rewrite x squared minus x minus 6. I rewrote it as x squared. I did it mentally though, x squared. Rewrote it as x squared minus 3x plus 2x minus 6. That's all I did. And then I factorized mentally, factorized out the x. And you have x minus 3 right there. So, and then I factored out right here. So now I factored out x again, 2 again. Then I get back my x minus 3. So I did it mentally. But over time with a lot of math, you'll be able to do it mentally as well. All right. So just for those who want to see it right there, you know, you put that step in. So from this, what we're ending up getting is that x is going to be equal to, from this, if you equate this to be 0, you get x is -2. If you equate this one to 0, you get x is equal to 3. Now, when you get your values for x, you don't finish. You need to find your y values. So when you plug 3 in this function, 5 minus 3 is 2. When you plug 3 in this function, when you plug -2 right here, so 5 minus -2 is 7. So that means you can tell them, say, m is a point -2, 7. That's m. And they can tell them, say, n is the point 3, 2. That's it. We didn't do nothing much, but that was nice. Cool. Next part now say, Monty is cycling at 12 meters per second. After 4.5 seconds, he starts to decelerate. And after a further 2.5 seconds, he stops. It says the speed time graph is shown below. All right, the speed time graph. And it tells we say, calculate the constant deceleration. So here is where the deceleration starts. He started to decelerate after 4.5 seconds. So the deceleration is just the gradient. This is the deceleration. So to find the gradient, right, I'm going to call deceleration -a. I hope that's fine with you. It's really negative acceleration. So the deceleration is the speed from right here. So y2 minus y1. Remember, it's y2 minus y1. So it's 12 minus y1. The y value right here, so it's now 0. Divided by x2. X2 is this value right here, 7 minus x1 minus 4.5. And that's going to give you, we'll plug that in our calculator. I'm just going to plug it straight in a calculator. All right, we're going to get 12 over 7 minus 4.5. y2 minus y1 over x2 minus x1. I wrote it the wrong way around. All right, so this is it though. This is fine. 4.8. So the deceleration is 4.8 meter per second. All right, the deceleration is 4.8 meter per second square. Now you might wonder what happened to the minus sign. You might say, sir, why you not have a minus sign? The answer for negative. No, I said the deceleration is 4.8. So in other words, the acceleration, Look what I'm saying now. In other words, I'm saying that the acceleration is negative 4.8 meters per second. So in other words, when you're negatively accelerating, you're decelerating. But since we already use the term decelerating, we know that it's negative acceleration. So we need to put a minus sign. That's all I'm saying. All right. But what if you did the physics? If you do physics, you learn, say, V is equal to U plus A times T, right? And you want to find A, you already know the final velocity is 0. That's equal to the initial velocity of 12 plus A times T. How long did it take to get to this speed? From 4.5 to 7, that's 2.5. So 2.5 A. And then you work out A. From this, you get A is 12, or actually negative 12 divided by 2.5. And you're going to get the same, negative 4.8. So using equations of motions in a straight line, this is doing it the physics way, you still get negative 4.8. This is physics way, using that formula there. All right, nice. Now this says find out what is Monty's average speed in over 7 seconds. Remember, average speed, to find average speed, it's total distance divided by total time. So first we need to find total distance. To find total distance, we need to find the area of this trapezium. So we're going to find the total distance. So the total distance, I'm calling the total distance. Let's call it ST, meaning the total distance. Distance is S. So the total distance is equal to the area of this trapezium. So just to write it in words so you can follow. Total distance is area of the trapezium. Area of trapezium. So to find the area of the trapezium, what we're going to do is area of the trapezium is equal to half the sum of the parallel sides. So this side have a distance of 4.5, this side have a distance of 7. So it's a half of 4.5 plus 7. Then you multiply it by the perpendicular height of 12. And that will give you the total distance. You plug that into your calculator. You just do so, 1/2. And then you multiply that by 4.5 plus 7 times 12. You punch all of this into the calculator and we get the beautiful number of 69 meters. And then what we then do to find the average speed, I'm going to call it V. I'm going to call the average speed V. I'm going to call it VA, meaning velocity average. Average speed is then the 69 being divided by 7. So work out that now, 69 divided by 7. So the average speed is 9.85. 9.85 meters per second. That's the average speed. His average speed is 9.85 meters per second. That's his average speed. All right, nice. Moving on.